let's take a quick look at an introduction to quadratics. So remember, a quadratic equation is going to be anything. It's going to be an equation that has x squared. The standard form of these things, which we're going to talk about in the next video, would be y equals a times x squared plus bx plus c, where a, b, and c are all numbers. They're numeric values. So we've been dealing with this a little bit already when we've been doing the when you guys were factoring. We factored things out of quadratic form to figure out what were the two things that it would break down into. So quick reviews here. The graph of a quadratic is called a parabola. And when you get to the max or minimum point, remember that's what's called a vertex. And then the line that goes through the vertex right through the middle, you can see it right here, that's called the axis of symmetry, which means pretty much what it sounds like, that this parabola is going to be the same on both sides of the axis. And then to find the solutions of a quadratic, that's where you go find the x-intercept. So you can see all that stuff on the graph to the right here. So see, there's the intercepts. The x-intercepts are what are called the solutions. And then you also have the y-intercept right here, and that's where x equals 0. So that point, that current point, right, if you were to plot that point, that'd be the point 0, -3. So that's where the y-intercept is. So quick practice here, identify the vertex and axis of symmetry. So very quickly, the vertex is right here, which would be the point 1, -2. And if we were to draw the line through the middle of this parabola, we'd have the line x equals 1. Here, the vertex is at -2, 4. And again, if we were to draw the line right through the middle, we'd have x equals -2. The next problems, here we've got the point 4, 3. And then the axis of symmetry is x equals 4. Notice that the vertex, the x part of the vertex and the axis of symmetry is the same number. And that's because the axis of symmetry goes right through the x. Right, here we go at -3, -3. And again, you can see that vertical line goes right through -3. So that the axis of symmetry goes through the vertex at the vertex's x point. All right, so finding solutions to these things. All you're looking for, the solutions are really, you're just looking for the x-intercepts, or where it crosses the x-axis. So let's take a look at this one. Here we got an intercept there, and here, so we have an intercept at x equals -3, x equals 2. Here you've got those two, so you have x equals -4, x equals -1. Here we've got the point x equals -2, and 1, 2, 3, 4, 5, 6, 7, 8, 9, x equals 9. And finally, we have two solutions there, x equals 1, x equals -1. So we can also draw quadratics given these criteria. So let's say we have a vertex is at 1, 2, and if it's a max, that means this parabola should go down, right? That would be the maximum point, the highest point on the graph. The solutions are -1 and 3, so we'll put a point at the x-axis at -1, 1 at 3. And sure enough, if we connect those points, we get a parabola that opens down, which means that that vertex was the highest point, so there's your max. Let's try the next one. So the vertex is at -2, -6. That's a minimum, which means this should open up. And then we need solutions at -5 and +1. So sure enough, if we connect those points with a parabola, it opens up. Alrighty. A little bit more in depth with solutions. Basically, there's three different things that these quadratics can have. And what happens is you either have two solutions, one solution, or what are called imaginary solutions. And really, solutions, the big thing with solutions, how many times it touches the quadratic, touches the x-axis. That's how many solutions you have. So you can see here, there's where it touches it twice. That's why there's two solutions. In the second example, it only touches once. Here, this parabola never actually touches the x-axis, does it? So it exists as a parabola, but there are no real solutions. So quick sketch, what's two real solutions? That means it has to have two x-intercepts. It has to touch the x-axis twice, so there you go. One real solution means basically the vertex has to be right on, and then it's done. And then two imaginary solutions, so just draw yourself a parabola that doesn't touch the x-axis. So, analyzing the key characteristics of a quadratic function. So now it's kind of putting everything together. So, first thing first, let's take a look at the vertex. Well, that vertex is at the point -2, 4. Now, is that a max or a min? Well, this is the high point, right? This is the highest point, which lends itself to being the maximum. Axis of symmetry, AOS. So draw the line through the middle, and you can see that goes through the line x equals -2. Number of solutions, aka how many times does it touch the x-axis? Well, it touches the x-axis at -4 and 0, so it has 2. And since it actually touches, they're going to be real. So what are those solutions? We have x equals -4 and x equals 0. Does this open up or down? Well, we can see it opens down. And then we go look here. Where does it cross the y-axis? It crosses the y-axis right here. So it's got a y-intercept at 0. Let's look at one more example on the next page, right in the middle. So the vertex. Here's the vertex, and it's at the point 3, 0. Since this thing is opening up, I'll go ahead and fill that in. This is a minimum, right? This is a low point. Axis of symmetry. Draw the line in there. That's at the line x equals 3. Number of solutions. How many times does it touch the x-axis? It only touches once. It's real. And so that solution would be x equals 3. Here we've got one that opens down. The vertex would be 7, 1. And since that's the high point, this is a max. The axis of symmetry would go right through 7, so x equals 7. Here there are two real solutions. Right? It touches the axis twice. And those solutions, x equals 6, x equals 8. And then we'll just finish the page out. Here, the vertex is at -1, -3. And this is one that opens up. And since it's opening up, that's the minimum point. And that's the lowest point. Axis of symmetry. Looks like it goes through x equals -1. This thing touches the x-axis twice, so we have two real solutions. One at -4 and one at 2.